Hello everyone. In today's lecture, we go with the concept of the chapter pair of straight lines. Previous year, we have studied the equation of line. We studied various forms of the line. Here, ax plus by plus c is equal to 0. Here A, B, C belongs to R, and here A and B not 0 simultaneously. We know this concept. Now in today's lecture, we go with our new concept in this chapter, and is here combined equation of line. And to define this concept, we have to use the definition of line. We have to consider various forms of the line. Okay, so we go with our concept here, combined equation of line. An equation which represents two lines. I repeat again, here an equation which represents two lines, then this is called the combined equation. Then this is called the combined equation of those two lines. Okay, let here u is equal to 0 and v is equal to 0 be the given lines. We define these two lines. Let here u is equal to or is equivalent to here a1x plus b1y plus c1 is equal to 0. Then we define v and is equivalent to here a2x plus b2y plus c2 is equal to 0. Now we consider these two lines to define the combined equation of the line. Okay, so to define this, we go with our one important theorem. Okay, so here theorem here in theorem statement is the equation uv is equal to 0 represents the combined equation of lines. Here u is equal to 0 and v is equal to 0. Okay, so remember this statement. Here the equation u into v is equal to 0 represents the combined equation of the lines. Here u is equal to 0 and v is equal to 0. Okay, so to define this theorem, we consider one figure. Here in this figure, we consider two lines. Okay, let us consider here first is u is equal to 0 and second is here v is equal to 0. Now we have to find the combined equation of these two lines. Okay, so we define these two lines. Here I write consider the lines represented by here u is equal to 0 and v is equal to 0. Let us consider forms of the given lines. Let here u is equivalent to here a1x plus b1y plus c1 is equal to 0. Then second, here v is equivalent to here a2x plus b2y plus c2 is equal to 0. Now we know these two lines. Let us consider one point on this line u is equal to 0. Okay, let us consider p of x1 by 1. P of x1, y1 be any point on the line u is equal to 0. Suppose this point P of x1, y1 is here, okay? Here is a P of x1, y1. So here I write let P of x1, y1 be any point on line u is equal to 0. Okay, if this point lies on this line u is equal to 0, this point satisfy the given equation, that is satisfy the equation here u is equal to 0. Okay, therefore P of x1, y1 satisfy the equation u is equal to 0. Okay, if this point satisfy the given equation u is equal to 0, then here I write therefore here a1 x1 plus b1 y1 plus c1 is equal to 0. That is, we replace this x and y by using here x1 and y1. Okay, now here we know this a1 x1 plus b1 y1 plus c1 is equal to 0. Now we have to show this given point P of x1 y1 satisfy the equation u into v is equal to 0. Okay, so here I write now to show the point P of x1 y1 satisfy the equation here u into v is equal to 0. Okay, now we have to define this equation. Let us consider this u into v, that is LHS. Consider u into v is equal to, okay, now we know here u is equivalent to here a1 x1 plus b1 y1 plus c1, since this point satisfy this u is equal to 0. Okay, so here I write a1 x1 plus b1 y1 plus c1 into, now we know equation of v. Here v is a2x plus b2y plus c2 equal to 0. Here I write a2x plus b2y plus c2. Okay, then this is equal to, we know here this a1 x1 y plus b1 y1 plus c1 is equal to 0. So we replace this bracket by using 0 into here a2x plus b2y plus c2. And we know here 0 into anything is always 0. So this is equal to 0. So the given point P of x1, y1 satisfy the equation u into v is equal to 0. Therefore, the point P of x1, y1 satisfy the equation, u into v is equal to 0. Since this point satisfy the given equation, here every point on the line u is equal to 0 satisfy the given equation. So in next line here I write therefore every point on line u is equal to 0 satisfy the equation u into v is equal to 0. Okay. Similarly for the second line, here v is equal to 0. Let us consider point on this line v is equal to 0 is here q of x2, y2 Okay, similarly we can show that every point on the line v is equal to 0 satisfy the equation here u into v is equal to 0. Okay, so here I write similarly every point on line v is equal to 0 satisfy the equation here u into v is equal to 0. Okay, so here every point on the line u is equal to 0 and every point on the line v is equal to 0 satisfies the given equation. Okay, so here we show our one part. Okay, now we consider another point r of x dash y dash which satisfy the equation u into v is equal to 0. Okay, so here I write let r of x dash y dash be any point which satisfy the equation u into v is equal to 0. If this point satisfies the given equation, here I write a1x dash plus b1y dash plus c1 into here a2x dash plus b2y dash plus c2 and this is equal to 0. Here everyone knows equation of u is here a1x plus b1y plus c1 and equation of v is here a2x plus b2y plus c2. Here this point satisfy the given equation, so we replace our x and y by using here x dash and y dash. Okay, then here I write this as here a1x dash plus b1y dash plus c1 is equal to 0 or here a2x dash plus b2y dash plus c2 is equal to 0. So here we say that the point r of x dash y dash also satisfy the equation of line or the line here u is equal to 0. Okay, so here I write therefore r of x dash y dash b point lies on u is equal to 0 or here v is equal to 0. So we say here every point which satisfy the equation u into v is equal to 0 is always lies on here u is equal to 0 or v is equal to 0. Okay, so here I write every point, therefore every point which satisfy the equation u into v is equal to 0 is lies on either here u is equal to 0 or v is equal to 0. So the equation, here we say the equation u into v is equal to 0. Here is the combined equation of the line u is equal to 0 or v is equal to 0, and this is we have to prove. So remember our statement of the theorem. The equation u into v is equal to 0 is the combined equation of the lines here u is equal to 0 and v is equal to 0. So remember this theorem. Okay, let us see one remark related with this combined equation. Okay, remark First one, the combined equation u into v is equal to 0 is also called as joint equation. Okay, is also called as joint equation of lines u is equal to 0 and v is equal to 0. So remember, here the combined equation is also called as joint equation. Then in second remark, we consider here u is equal to 0 and v is equal to 0. These are called the separate equation of the lines u into v is equal to 0. Are called separate equations of lines or separate equation of lines represented by u into v is equal to 0. Okay, so remember this point also. I repeat again, here the combined equation is also called as the joint equation, and here u is equal to 0 and v is equal to 0 are called the separate equation of the line represented by here u into v is equal to 0. So in today's lecture, we go with some examples related with this combined equation. Okay, so example, let's go with first one. Here given, find the combined equation of the following pair of lines, Here in first given 2x plus y equal to 0, 2x plus y is equal to 0, and second here 3x minus y is equal to 0. Now here given two lines. Let us consider first is u, second is v. Let's define these two lines. Let here u is equivalent to here twice x plus y is equal to 0. Then we consider v. Here v is equivalent to here 3x minus y is equal to 0. Now we know u and we know v. We also know the combined equation of these two lines is u into v is equal to 0. Here I write, we know that the combined equation of lines u is equal to 0 and v is equal to 0 is u into v is equal to 0. Okay, so here we know u, we know v. Okay, so we replace here u and v. Therefore we know here for u given 2x plus y, here 2x plus y into here for v given 3x minus y, so into 3x minus y, and this is equal to 0. Now we consider product of these two. Okay, firstly we multiply second bracket by 2x, we get here 2x into bracket 3x minus y. Then we multiply this second bracket by plus y. Okay, so y into bracket 3x minus y is equal to 0. Okay, then we multiply this bracket by 2x. If we multiply, we get here 6x square minus Then 2x into y is 2xy. Next, we multiply this bracket by y now. Okay, so 3x into y is 3xy. Then here y into y is y square, so we get minus y square is equal to 0. And lastly, here we get 6x square. Then we know minus 2xy plus 3xy. We know this is xy, okay, minus y square as it is, and is equal to 0. And this is the required combined equation. Okay, this is required combined equation. Okay, and this is we have to find. Okay, so very simple example it is. Let's go with our second example. Let's go with second example. Here in second, given x plus 2y minus 1 is equal to 0 and x minus 3y plus 2 is equal to 0. Again, given two lines. Okay, let us consider first as here u is equal to 0, second as here v is equal to 0. Let's define these two lines. Let here u is equivalent to x plus 2y minus 1 is equal to 0. Then consider second, here v is equivalent to x minus 3y plus 2 is equal to 0. Okay, now we have to find the combined equation. And here we know the combined equation of lines. Here I write, we know the combined equation, of lines u is equal to 0 and v is equal to 0 is here u into v is equal to 0. We know this. Okay, now we replace u by using x plus 2y minus 1 and v by using here x minus 3y plus 2. Okay, so here we get x plus 2y minus 1 into, here for v we consider x minus 3y plus 2 and this is equal to 0. Now we consider product in between these two. Okay, let's multiply this second bracket by x first. Okay, therefore here x into bracket x minus 3y plus 2. Then we multiply the second bracket by plus 2y. Here plus 2y into x minus 3y plus 2. Then we multiply the second bracket by minus 1. Here minus 1 into x minus 3y plus 2 and this is equal to 0. Okay, now in next step we multiply this first bracket by x. Okay, if we multiply we get here x square minus 3xy then plus 2x. Now here in next let's multiply this bracket by 2y. If we multiply we get here plus 2xy then minus 6y square. In last here plus 4y. Then we multiply this bracket by minus 1. If we multiply here we get minus x plus 3y minus 2 and is equal to 0. Okay, now here I write this as here x square. I write first x square, then here we consider minus 6y square. Firstly I write x square, then I write here minus 6y square. Okay, next we know here minus 3xy plus 2xy. We know minus 3xy plus 2xy is minus xy. Then here 2x minus x is plus x. Then here 4y plus 3y is 7y. Then in last, here we have only -2 and this is equal to 0, and this is the required combined equation of given two lines. Okay, so this is required combined equation. This is required combined equation. Okay, so very simple example it is. Let's go with third example. We consider find the combined equation of pair of lines. Find the combined equation of pair of lines passing through point 2, 3 and perpendicular to the lines here. Given lines are 3x plus 2y minus 1 equal to 0, and here x minus 3y plus 2 is equal to 0. Here again we have to find the combined equation, and for this here given our line pass through the point here 2, 3, pass through the point 2, 3, and our lines perpendicular to the given lines. Our lines perpendicular to the given lines. Okay, so we consider our required lines are here L1 and L2. Our first step is we have to find lines L1 and L2. Let's define these two lines. Let L1 and L2 be the lines passing through point here given 2, 3 and perpendicular to the lines here 3x plus 2y minus 1 equal to 0, and here x minus 3y plus 2 equal to 0. So we define our lines L1 and L2. Okay, this is our required lines. Now we consider our given lines. To find the combined equation or to find our required lines, firstly we consider slopes of the given lines. Okay, so here slope of line 3x plus 2y minus 1 equal to 0 is m1 is equal to, we know here slope is minus 3 upon 2. Remember, if ax plus by plus c equal to 0 is our given line, then its slope is minus a upon b. Similarly, here slope of line 3x plus 2y minus 1 equal to 0, here is minus 3 upon 2. Okay, similarly, we consider slope of second line. Here slope of line x minus 3y plus 2 equal to 0 is m2 and is equal to, here slope of this line is minus 1 upon minus 3. We know here minus 1 upon minus 3 is here plus 1 upon 3. Is plus upon 3. Okay, so here we know slope of the given lines. Here condition is given, our lines, our required lines are perpendicular to these lines respectively. Okay, so here I write, since since required lines are perpendicular to given lines. Okay, here I write slope of L1. Therefore slope of L1 is equal to, slope of L1 is here minus 1 upon M1. Okay, let us consider here L1 is perpendicular to the first line, L2 is perpendicular to the second line. Okay, so here slope of L1 is minus 1 upon M1 is equal to minus 1 upon, we know M1 is minus 3 upon 2. Okay, so here minus 3 upon 2, and lastly we get here 2 upon 3. Similarly, we find slope of line L2. Therefore also okay, here I write and slope of L2 is equal to minus 1 upon M2 is equal to minus 1 upon, here slope of M2 slope of second line is 1 upon 3. So here we get minus 3. Here we get minus 3. Okay, now we know our slope of the required lines, that is L1 and L2. Let's find equation of required lines. Okay, therefore equation of L1 is, now here we know for our form, here y minus y1 is equal to m into x minus x1. Okay, here x1 y1 point is given. Remember here 2 3 is the point and is x1 y1. Okay, so here we know y minus y1, here y1 is 3. Okay, so y minus 3 is equal to slope of first line is 2 upon 3 into x minus x1, we know x1 is 2. Okay, so here x minus 2. Then here we get 3y minus 9 equal to 2x minus 4. And lastly, here we get 2x minus 3y plus 5 equal to 0. And this is the equation of L1. Similarly, we find equation of L2. Also, equation of L2 is, again we consider our form, here y minus y1, we know y1 is 3 equal to, here slope of second line is minus 3, okay, into x minus x1, x1 is 2, here x1 is 2. Then here we get y minus 3 is equal to minus 3x plus 6, and lastly here we get 3x plus y minus 9 is equal to 0. Now here we know our first line L1, our second line L2. Let's find its combined equation. Okay, so here I write, therefore the combined equation is, here equation of L1 is here 2x minus 3y plus 5 into, here equation of L2 is 3x plus y minus 9 is equal to 0. Okay, then here we get, let's multiply this bracket by 2x first. If we multiply, we get 6x square plus 2xy, then minus 18x. Now we multiply this bracket by minus 3y. If we multiply, we get here minus 9xy, okay, then minus 3y square, and in last here minus 3y into minus 9 is plus 27y, since minus 3 into minus 9 is plus 27. And in last, we multiply this bracket by 5. Here I write plus 15x plus 5y minus 5 into 9 is 45 is equal to 0. And lastly, here I write this as, here in first we consider 6x square, then we consider minus 3y square, then here we consider 2xy minus 9xy is a minus 7xy, then we consider minus 18x, here minus 18x plus 15x, minus 18x plus 15x is minus 3x, then here plus 27y plus 5y is plus 32y, then here constant is minus 45 and this is equal to 0. So 6x square minus 3y square minus 7xy minus 3x plus 32y minus 45 equal to 0 is the required combined equation. This is the required combined equation. So in these three examples we find the combined equation. Now we have to find the separate equations for the given equation, for the given combined equation. Okay, so we go with our next example. Find the separate equations. Find the separate equations of lines represented by following equation. Okay, let's go with first one. Here in first given 3y square plus 7xy is equal to 0. Okay, consider this equation again. Consider here 3y square plus 7xy equal to 0. Here combined equation is given. We have to find its separate equations. That is u is equal to 0 and v is equal to 0. Now here consider y as common. Okay, so y into bracket 3y plus 7x equal to 0. Then we write this as here y is equal to 0, here y is equal to 0 and 7x plus 3y is equal to 0. So here the separate equations are, therefore the separate equations are y is equal to 0 and 7x plus 3y equal to 0. So these are the required separate equations. Okay, now we go with second example. Here in second given 5x square minus 9y square is equal to 0. We have to find separate equations, that is u is equal to 0 and v is equal to 0. Consider the given equation again. Here 5x square minus 9y square is equal to 0. Here I write this 5x square as root 5 into x, this bracket square, minus, here I write 9y square as here 3 into y square is equal to 0. Now we know this is in the form a square minus b square, and we know a square minus b square is a minus b into a plus b. Okay, so here I write root 5x minus 3y into, that is a minus b. Now we consider a plus b, means root 5x plus 3y is equal to 0. Then here I write this as root 5x minus 3y equal to 0, and for second here root 5x plus 3y is equal to 0. So these are the required separate equations. Therefore, the separate equations are, here I write, therefore the separate equations are given root 5x minus 3y equal to 0, and here root 5x plus 3y is equal to 0. Okay, so in today's lecture we define combined equation of line. Okay, then we see how to find the combined equation of a given pair of lines. Also, we see how to find the separate equation of given lines represented by the following equation. Okay. In next lecture, we see another concept related with the chapter here, pair of straight lines. Thank you.